Let's continue learning Excel and how Excel can be used in analyzing data. In this video, we will learn how regression analysis is performed. As you can see, regression analysis is a set of statistical methods used for the estimation of relationship between a dependent variable and one or more independent variable. So you see there are three kind of regression analysis: linear regression, multiple linear regression, and no linear regression. For the sake of simplicity, we'll be using linear regression with only one independent variable. Now, I'll be using a data set where I have sales in millions and number of ads which are used to generate the sales, and hence the sales become dependent variable, and this sales depends on number of ads which are shown on TV as independent variable. Hence, sales is Y variable and number of ads is X variable. Now we'll be plotting a chart to check the relationship between X and Y variable. For that, I select both these variables or both these columns. I go to a scattered plot, and when I plot a scattered bar, you would see all these dots are getting plotted. So on the x-axis I have number of ads, whereas on the y-axis I have sales in millions. What I would do now is I will be adding a trend line, and to add a trend line I actually go to the options and I add a linear trend line. Along with the linear trend line, I would also say display the equation on the chart and display R square value. When I do this, you would observe that it has plotted a trend line and all the dots are very close to this trend line, which means that there is a good relationship between these two parameters of these two variables I have. And when I look at the equation, it says y is equal to 71.9x plus the intercept, which is 8479. So the 71.988 is the slope of the curve and 8479 is the intercept. And this particular thing y equal to beta x plus constant becomes my equation for regression, linear regression. When I check the R square, I see the R square is 0.92, which is considered to be a very good R square, and that means this model actually fits. Now this equation also helps me to plot the next y value given I have the x value, the next x value. We will see that later. How can we use this equation and how can we forecast the values for the upcoming x's? But let's explore various other ways to perform regression analysis in Excel. Excel provides another way to perform regression analysis, and that is using data analysis add-in. Now, if you do not have this add-in enabled, what you need to do is you can go to File, Options. Within that, you have add-ins. When you go to add-ins, you can go to Manage Excel add-ins, click Go and check Analysis Toolpack, or the shortcut is Alt TI. And when you press this, you can enable by ticking this Analysis Toolpack. When you do that, this data analysis would appear in your under your data tab, and when you click on this you would see various analysis tools available in Excel. Now I'll be selecting regression. When I select regression, you would see it asks for input range. My input range is the y variable, which is sales in millions, and I select labels. So this particular range has a label. In the X, I would select column A, and this also has labels. And when I say output, my output should be displayed here. When I click OK, it generates a summary of this regression. And what it suggests is that the R square looks good, which we have seen on the chart as well. And when you come below, the third table talks about intercept, which we saw on the chart, and the slope of the curve. Excel also has formulas to calculate slope and intercept. So to calculate intercept, what I need to do is I need to calculate intercept, known y's, or these are all my known y's, known x's, these are all my known x's. When I press this, it gives me the same intercept as we got on the chart as well as in the regression analysis using data analysis add-in. Now coming to slope, so you can again there is a formula to calculate slope. It also asks for known y's and known x's. When I do this, it gives me a slope of the curve as well. There is another function which gives me slope and intercept. This is an array function. When I say linest, it known y's, these are my known y's and these are my known x's. When I press enter, it gives the coefficient as well. And let me do it again. Linest, known y's and known x's. It gives both slope and intercept. Now, how do we use this slope and intercept to come up with the next y or to forecast y? The formula or the equation which was mentioned in the first table or first tab is basically x equal to a plus bx, whereas a is basically your intercept, b is slope, and as we know, x is the value which is varying. Now, if I know the x is 200, what would be my sales in millions? And to do that, so my sales, which is y, equal to slope multiplied by, so that, slope multiplied by x plus intercept, and I get the next sales value, which is going to be 28,876. Similarly, I can actually calculate the sales for the next values as well. If I say my ad spend or number of ads are going to be 20 or 250, I can say that my sales value is going to be slope multiplied by x plus intercept, and I would be getting a better sales than showing 200 ads. The last way to forecast the values is I will show you is the forecast function itself. Let's say I have 300 as the number of ads. I have forecast function or forecast formula which uses the same linear regression concept and forecasts the values. So it is asking for x, and this is my x, all the known y's, and I would select the known y's as this, and known x's, I would select all the known x's, and it gives me, if I have 300 ads, my sales is going to be 30K. Thank you for watching this video. I hope you will be able to implement regression in your data analysis. Thank you.